Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 21 to 24 of the January 2019 Algebra 2 New York Regents exam. All right, let's take a look at question 21. In this problem, we're being assessed on how to simplify rational expressions, okay? Question 21 reads, which expressions are equivalent to x squared minus 4x divided by 2x, where x is not equal to 0. All right, so we have three rational expressions here, and we want to see which one are equivalent or equal to this expression that we have right here. Okay, so what we're going to do first is we're going to use the simplification approach. We're going to start with the original problem, x squared minus 4x over 2x, and we're going to simplify it in two different ways. Okay, the first one will involve decomposition into two fractions and reduction, and then the other will involve factorization and then reduction. Alrighty, so let's go ahead and decompose this first into two fractions. So remember the idea with addition or subtraction of fractions. Basic arithmetic, right? A over b minus c over b is equal to a minus c over b. Okay? As long as the denominators are the same, what you do is you add or subtract the numerator and keep the denominator the same. So what if you have a minus c over b? You can decompose, you can reverse the process, right? So you just take the first term over the denominator minus the second term over the denominator. We're going to do exactly the same thing here. Okay? We're going to take the first term, which is x squared, divided by the denominator, minus the second term, which is 4x, divided by the denominator. All right? So we're reversing the difference of two fractions. Okay, so we've decomposed it. That's what the name is of the procedure we just executed. Now we're going to simplify. Okay? X squared divided by 2x. This is x to the first power. So if we're dividing this out, we have 1 over 2. So that 1 over 2 stays there. X squared divided by x to the first power. So what we're going to do is we're going to subtract. Okay, so x to the first goes here once, and then you just subtract this power from the bigger one, minus 1. All right, using the quotient property of exponents. Whenever you're dividing exponents with the same base, you subtract the powers. Okay, so we're going to have x to the 2 minus 1, which is just x to the first power, divided by 2. Okay, minus 4 over 2x. We could divide the numerator and the denominator by 2. So divide this by 2, divide that by 2, right? 4 divided by 2 is going to give us 2, and then 2 divided by 2 is 1. And the x's divide out also. So you just have x over 2 minus 2. And that's equivalent to option 1. So option 1 is good, is equivalent to the original expression. Now this was the decomposition and reduction approach. Now let's go ahead and use the factorization and reduction approach. Okay, so x squared minus 4x divided by 2x. Now we can factor out the GCF from the numerator. Okay, if you look at the numerator, we have x times x minus 4 times x divided by 2x. You notice that in the numerator, x and x is a common factor. So we can factor that out. X over x minus 4 divided by 2 times x. Now we can reduce. If we reduce, what do we get? X goes here once, x goes here once, and your final answer is x minus 4 over 2. That's the reduced form when we factor and reduce. That is equal or equivalent to this one right here, option 2. So option 1 and 2 are equivalent. Now how about option 3? Option 3 looks a little bit complicated. X minus 1 over 2 minus 3 over 2. We simplified the original problem using two methods, and we arrived at these two options right here. So we've already exhausted our possibilities, okay? So in order to attack this one right here, what we're going to do is we're going to work from the answer to the question. Let's simplify this completely and see if we arrive at the question. All right? Okay, so if you notice, we have two fractions with identical denominators. So what does that enable us to do? We have x minus 1. We just subtract the numerators, right? X minus 1 minus 3, and combine the denominator, minus 2 over 2. What does that become? X minus 1 minus 3 is negative 4. X minus 4 over 2. Hold on, wait a minute. This is exactly equal to option 2, which is equal to the original question. So guess what? Option 3 is also equivalent to x squared minus 4x over 2x. Okay? So the answer to question number 21, which expression is equivalent to this, is option 4, which is 1, 2, and 3. All right, so a question for you. Which simplification approach do you prefer? Option 1 or 2? In option 1, we decomposed and reduced. Option 2, we factored and reduced. So let us know which decomposition method you prefer and why. Just post your answer in the comment section below. Okay? All right, let's take a look at question 22. In question 22, we're being assessed on how to find the maximum and minimum of quadratic functions. Okay? In question 22, we're going to be looking at finding the extrema of the function and the graph. Question 22 reads, consider the function f of x equals 4x squared plus 6x minus 3 and p of x defined by the graph below. We know that this is a quadratic because the graph is a parabola, okay? And all parabolas are quadratic functions. Question, the difference between the values of the maximum of p and the minimum of f is? So what we are looking for in this problem, we're basically trying to find the difference between P max and the difference between the maximum of P and the minimum of F min. Okay, so all we're just looking for is P max minus F min. All right, let's start by looking for F max, okay? We want to find F maximum. No, F minimum. All right, because we asked the minimum of F. So to find F minimum, we need the following formula. Whenever you're given a quadratic in its equation form, on an algebraic form, the formula for finding the minimum or the maximum, in this case the minimum, is going to be the function evaluated at negative b over 2a. Okay? All right, so let's call up the f of x function. F of x is 4x squared plus 6x minus 3. A is 4. A is 4. B is 6. And C is negative 3. We don't need C for this problem. We just need A and B, 4 and 6, okay? All right, so what is negative b over 2a? Negative b over 2a represents the x-coordinate of the vertex. Okay? And when you plug that into the function, it tells you what the minimum is. Negative b over 2a is going to be negative 6 divided by 2 times 4. This becomes negative 6 over 8. Divide top and bottom by 2, and you have negative 3/4. Okay? Now, to find what f min is, you're just going to evaluate the function at negative 3 over 4. Okay, so what we're going to do is plug in negative 3 over 4 into this function. So f of negative 3 over 4 is going to be 4 times negative 3 over 4 square plus 6 times negative 3 over 4 minus 3. All right, you can use order of operations to work this out. But since we have the luxury of using a calculator, let's go ahead and use a calculator to calculate what this is. So we have 4x raised to the second power, 4x squared, plus 6x 6x minus 3. Enter. So we're going to store negative 3 over 4. Negative 3 over 4. Where are we going to store it? We're going to store it in x. Okay, so store that in x. And then let's call back the function that we just entered. Second function, enter. And then we get negative 5.25. Another way you can do this is by using your table function. You go to y, enter it into y, and then look for what the output is. Let me show you how to do that real quick. So if you have 4x squared plus 6x minus 3, enter. And then you go to the table setup. So this is the table setup right here on the top of window. So if you go to the table setup and you ask the calculator to ask you for the independent variable. All right. If you ask it to ask you, then you can specify what you want to find the output for. So we want to find the output for negative 3 divided by 4. Enter. Negative 5.25. So that's just another way to do it. Or you can graph the function. Just graph it. And then you use the trace option. Okay, so you hit trace, right? So when you hit the trace button, you can just enter negative 3 divided by 4 and hit enter, and then it tells you what the output is, negative 5.25. So those are 3 different ways that you can do it. Or the fourth way is you can just work this out using the order of operations. Whichever way you do it, f of negative 3 over 4, which is f min, is equal to negative 5.25. Now, we're asked to find P max minus F min. We don't know what P max is, so let's go ahead and find P max. P max can be determined using this graph. So all we do is we are going to trace the x axis to the, this is the maximum right here, okay? So what's the output right here? That's what P max is. The y-coordinate of the peak of the function. This is the maximum right here. That's the maximum. And this value, which is 5, is your P max. Okay? So P max is 5. It's basically the y-coordinate of the vertex. So P max graphically is the y-coordinate of the vertex, which is 5. So P max is 5. So the difference between the maximum and of P and the minimum of F is 5 P max minus F min, which is negative 5.25. Signs are the same. You just add. So it's going to become a sum, slash and dash, and your answer will be 10.25. Your answer to question number 22 is option number 4. Okay, so this is how you find the extrema of quadratics graphically or using your calculator. All right, let's take a look at question 23. In 23, we're going to be assessing how to use the normal distribution curve, the mean and standard deviation to determine the amount of population that falls within a certain percentage boundary where the population is distributed normally. Okay. Question 23 reads, the scores on a mathematics college entry exam are normally distributed with a mean of 68 and a standard deviation of 7.2. Students scoring higher than one standard deviation above the mean will not be enrolled in the mathematics tutoring program. How many of the 750 incoming students can be expected to be enrolled in the tutoring program? Okay. All right. So let me give you a visual of what's going on here, and then we can use our calculators to finish off the problem. So it's indicated here that the scores are normally distributed, so it looks like a typical normal curve. Just a rough sketch here. So just a typical normal curve. All right. Right in the center we have the mean. All right. And then we're told that the students that score one standard deviation above the mean, so this is one standard deviation above the mean, they're not going to take the will not take the test. So this population right here will not take tutoring. Okay, not enrolled because their scores are pretty high. All right, they're not going to be enrolled. But the population that falls in this bracket right here, beneath one standard deviation from the mean, everybody in this space right here will be enrolled because your scores are not high enough. Okay, so will be expected to enroll. Okay, we'll be enrolling. All right. So there are 750 students in general. So what percentage of the population of these students fall in here? Okay. So if we can determine what the percentage of the population falls in this category, which is less than one standard deviation from the mean, then we can just multiply that by 750 to determine what their numbers are. Okay, so we don't have a normal distribution curve here, so we're going to be using our calculators to help us with that. We're going to be using normal cumulative density function feature of the calculator to do it. Okay, so normal CDF, we're just going to enter the minimum value, the maximum value, the mean, and the standard deviation. And then it's going to tell us, it's going to return to us the percentage of the population that falls in that bracket. So we're looking for everything beneath one standard deviation. So we're going to be going from 0, that will be our low point, to one standard deviation above the mean. So one standard deviation above the mean is basically going to be the mean plus one standard deviation. In this particular case, the mean is what? 68. So we're going to be adding 68 to one standard deviation, which is 1 times 7.2. If you add it up, you get 75. 75.2. All right. Let's go ahead and list all the things we know. Okay, so the minimum is the lower bound, which is 0. The maximum is one standard deviation above the mean, which is 75.2. We just calculated that. The mean is 68, and the standard deviation is 7.2. So just enter all that into the calculator. All right, and then it will tell us what the percentage is. So we're going to be using the TI-84. So go to second function variables to access the distribution feature. Scroll down to normal cumulative density function, hit enter. Now, syntax: minimum 0, comma, where's the comma button? There you go. Maximum is 75.2. The mean is 68, and the standard deviation is 7.2. Okay, enter. So it tells us that 84%, 84.13% of the population fall here. Okay, so let's put that 84.13%. So we can put that in here. 84.13%. All right, so we're going to look for 84.13% of the total population. Okay, so number enrolled in tutoring is basically 84%, 84.13% of the total. All right, so 84.13% is 0.8413, basically what we saw in the calculator. And then just multiply that by the total number of students, which is 750. Okay, so since I already have the percentage value here, all I'm just going to do is hit the times button. And you see this answer, it automatically inserts the previous answer as the first argument in our product. And then we're going to multiply that by 750. So 84.13% of 750 is 631. So we cannot have fractional students, so we're just going to round down. So it's going to be 631 approximately 631. So the answer to question number 23 is option number 1. All right, in question number 24, we're going to be taking a look at how to solve a system of rational and absolute value equations graphically. All right, so how do you solve systems graphically? We're going to be using our Texas Instruments TI-84 to solve this system of equations. So let me write down what a system of equations are first, and then we're going to solve it. Okay. So we have one function on the left, the rational, and an absolute value function on the right. So what we're going to do to solve this graphically is set y equal to both of them. So the first equation is y equals 1 over 1 minus x squared. And then the second one is y equals negative absolute value of 3x minus 2 plus 5. So a system of equations are two or more equations with related unknowns. All right? So you can see the x's and the y's as the related unknowns. Now, if you have a system of equations like this and you want to solve it graphically, there is something that you have to remember. Recall the following concerning the graphical solutions to a system. Graphical solution. So what you want to remember is that the graphical solution to a system of equations are the points of intersection. So wherever you have a point of intersection between the two or more functions that you graphed, those points of intersection represent the solutions. This problem is asking us for how many solutions. So based on what we wrote right here, what we're looking for is the following. Number of solutions is equivalent to the number of what? Number of intersections. Okay, so what we're going to do is we're going to graph these two functions, and then we're going to look for the number of intersections between the two, and that will tell us the number of solutions. Okay, all right, so fire up your TI graphing calculator. The first is irrational. We have 1 divided by parentheses 1 minus x to the second power. Close that. Enter. Second is an absolute value function. Put a negative, not minus, negative. For absolute value, press second function catalog. There goes your catalog button right there. Second function catalog. ABS is absolute value, so hit that. ABS 3x minus 2. 3x minus 2. Close that. Plus 5. Enter. Okay, so we have the two graphs. We're going to graph them right now. So there goes the rational, and there goes the absolute value. All right, so I'm going to zoom in a little bit. I'm going to use the zoom box to zoom in a little bit into the regions that the intersections are, so we can have a better view of what's going on, and then we can count the number of intersections that there are. Okay, zoom that down. All right, so capturing all the intersections. Let's zoom it in a little bit. All right, there goes your rational, and there goes your absolute value function. Okay, I just took a snapshot of the region we just graphed, so I just took a snapshot of this region right here. All right, so we're looking for the intersections. Do you see the intersections between the two functions? You have one intersection hit there, 2, 3, 4. What does that tell us? We have 4 intersections. That automatically means that we have 4 solutions. All right, so let's write that down. Since there are 4 points of intersection, that implies that there are going to be how many? There are 4 solutions to the system. Okay, And then if you look at the options that we have here, the answer to question number 24 is option number 4. Now, a question that I have for you: why do you think it's beneficial to be able to solve systems of equations using a calculator? Well, I would like to know what you think. Post your answer in the comment section below. Let us know your insights concerning why it's beneficial to be able to solve a system of equations using a graphing calculator. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any special requests for any math problems you'd like to have us solve, or any question in general, just post it in the comment section below and we'll be more than glad to respond. Don't forget to check our website, mathgotserved.com, under New York Regents for other updates and great review resources for your Regents exam. Thanks again for watching and have a wonderful day. Goodbye.